Here we're going to study the triboelectric series. How do you know what the charge of an object, right, positive or negative? How do you know what that charge is? Well, you could test it against a known charged object to determine the charge of the unknown. For example, we could actually rub a balloon on our shirt, and we've stated several times that the rubber balloon is going to gain a net negative charge. If we gain the net negative charge, if we tested that rubber balloon against another object and it repelled, well, we could safely say that the other object has a negative charge. If it was attracted to the other object, we could say the other object had a positive charge. And if there was no interaction between the charged rubber balloon, we could say that the other object must have been neutral or neutrally charged. But for convenience, scientists developed what's called the triboelectric series. Materials on the positive side, I'm going to call this the top up here. I'm going to keep kind of taking your eyes over here. On the positive side, have a greater affinity or a tendency to give up electrons than those on the negative side. When any two materials are rubbed together, right, via friction, the one which is on the negative side is expected to pull the electrons from the material on the positive side. In other words, these down here on the negative side are more apt to gain electrons, therefore having a net negative charge, and those on the positive side are more apt to donate electrons. They're givers of electrons, and they're going to end with a net positive charge. So using the table below, predict the charges of each of the objects in the descriptions below. In other words, you should be able to use this and apply that to a rubber balloon against the cotton shirt. You'll find that cotton shirt is on the positive end. It's going to give up electrons to the rubber balloon. So the rubber balloon will be negative, cotton will be positive charge after the friction. Rubber balloon against a wool shirt. Well, wool's even further up here. So a wool shirt compared to that rubbed against a rubber balloon compared to that of cotton, there's going to be a greater charge on the rubber balloon that's further from the wool. Look at the distance covered from the wool to the rubber balloon. There's what, 2, 4, 6, 8 or 9 boxes, whereas cotton is only 1, 2, 3, 4, 5. So the greater the difference, the greater the net charge. So a copper pipe rubbed against your skin. Notice your skin hands here, you'll see that are very, very willing to give it up. Human skin is a little bit less willing to give it up. In other words, your hands have a little different characteristics to give up electrons, where so your hands will give it up differently than your skin. So copper, we can find copper is going to be on the negative side. Here it is, copper. So notice copper is going to be negative, skin will be positive, and you can do that with the plastic ruler and rabbit fur. The triboelectric series, kind of part 2. Since materials are commonly neutral, right? Naturally occurring objects are pretty neutral. When you rub objects together, it relocates the valence electrons. It transfers some of the from the object on the positive side to the object on the negative side. So the materials on the positive side will have the greatest tendency to become positively charged. This is due to a loss of valence electrons, whereas those on the negative side become negatively charged by the addition of electrons. When we talk about the triboelectric series, it's very important you start realizing that there's relationships as to if something is giving electrons, it's going to end positive, and something is gaining electrons, it's going to end up negative. However, conservation of charge tells us that if an object loses 5 electrons, it has a positive 5 charge, and that the object that gained the electron is going to have a negative 5 charge. There you have it on triboelectric series.